Hello Paul, I'm the most excellent community of developers interested in discovering the mysteries of a Raspberry Pi and more specifically GPIO for the moment. So in last lesson we saw that it was possible to set up push-up, push-down resistors with a specific external resistor. So if we just here remind this, we had here 3.3 volt, okay, which was led through a resistor to a input pin. We have chosen pin 40 here, and we had here a switch that was leading to the ground. Yes, that was our setup. And what we see now is that this part here can be managed directly from within the Raspberry Pi, and we can send high signal directly from software. So this will simplify our circuit. Which becomes just a switch leading to the ground. And in my case, so that you can see what I do on my board, you'll see that I use pin 11, which is a GPIO 17. I just changed just to rearrange the design, so that I have a part for the LED and another part for the reading of the switch, which is less messy. So just using 11s instead of 40, but the principle is just the same. So if we have a look here on our board, you'll see above, the part above here, will pop up here. We just have two cables and the switch in between. Okay, that's why I say I just managed to have one side of the board for the reading of the switch, and the other side to drive the LED part doesn't change here. So difference here is that we have to drive or set up input with a additional parameter, which is here pull up down parameter, which is set here into up, which means that it will be high when the switch is released, and low when it's down. And I put it on 11, as I told you. Okay, and the 40 here is used to drive the LED, so we set it on out. Basically, the system here is to toggle the state of the LED on or off each time we push on the button. So we can use here a variable, I call it LED state, initial let state is 0, and I will use this let state to toggle it 0101 using a Boolean operator here. So when it's a 0 it becomes 1, when it's 1 it becomes 0, just because of the equivalence in Python between true value and one value. So there is an equivalence between an integer 1 and a Boolean true on one side, and an integer 0 and Boolean false. So it's automatically usable in our code. Okay, so the toggle operation is just here. If button is pressed, which is read value is low, as we said, because we are in up mode. If the button is pressed, then I toggle. Okay, so basically it would be enough to toggle, but problem is that we might fall asleep on the button and press it very lengthy. Keep the button pressed. What will happen if I keep the button pressed? During the time that the button is pressed, I will still toggle on and off, which could be considered as a messy situation. Okay, so that's why I need a additional variable here, which I call button up, which is true at the beginning, and when I toggle, I set button up to false, which is true because the button is down. Okay, there is no in between, so if it's down it's not up, so button up is false. And then I add here a condition. I toggle the LED state if, of course, the value is low and button up is true. It means that I come from an up value. Okay, so this time I can test and toggle only if both conditions are true, and when I press the button the LED will stay lit, will stay on, and of course when I release the button it will stay on. I don't retoggle. Okay, I have another possibility here, is that I have released the button. Okay, and this time I will say that button up is true. And that's it. So these variables here, I make a print just for debug, but the driving of the LED is here. GPIO or G.output on pin 40, which was out pin, and I use the LED state here, which is 0 or 1, which is understood as high or low, same So it can be used directly too. Then I sleep for half a second. Okay, I will launch this. Hold your breath. Okay, 1 0 1 0 1 0. Okay, I will press here and it's on. I keep the button pressed. Okay, I release, it stays on. No, I push and I release and it goes off. And I push and I release, it goes on. Looks that it works. And we deserve a sip of nice coffee. Thank you for watching. See you soon for the rest.